Okay, so this is again the nitrite, NO2 minus, nitrite ion. So here you can see the lone pair. So repulsion of lone pair will decrease the bond angle 115 degree. Now this is the odd electron species. Okay, NO2 odd electron species, 7 electron system. So the Lewis 7 electron, this is a lone pair, 7 electron system. Okay, so the repulsion of single electron and repulsion of a pair of electron. Now you can see 115 and 132. The single electron will repel less. Okay, then it is 132 degree, not less than 120. Okay, so odd electron species don't use the concept we are using for a complete octet Lewis structure. Okay, so it is an odd electron species. Now this is very simple. There is no lone pair, so it is 180 degree linear. Nitronium ion. Okay, nitronium ion. Okay, now next page. Phosphate, sulfate and perchlorate. Those who don't know the name, phosphate, sulfate and perchlorate are, they all are isostructural. Okay, so they all are isostructural as well as isoelectronic. You know the meaning? Isoelectronic means same number of electron in total species. You have to count total electron. Total. Okay, and they have same structure, that's why they are isostructural, that is sp3 pyramidal. Okay, draw the structure and find out the bond angle. I will ask in the next class. Okay, now day 3 I will ask what is the bond order or in each case. Now CCl4 and SiCl4, carbon tetrachloride and silicon tetrachloride they are only isostructural. They are not isoelectronic because carbon and silicon, कार्बन के बड़े भाई साहब हैं सिलिकॉन. ओके, तो आइसोइलेक्ट्रॉनिक नहीं हो सकते. इसमें एक मजे की बात क्या है कि इसको अगर हम वाटर से ट्रीट करें तो कुछ नहीं होगा, इट विल नॉट हाइड्रोलाइज. But when you treat with this water or some alcohol, it will hydrolyze. So say take alcohol, ROH, you can take ROH. So it will require 4 mole of ROH. It will be SiOH, SiRO. It will be SiOR whole 3 along with 4HCl. It will hydrolyze. Anybody? What is the answer? Availability of the vacant d orbital. Hydrolysis is possible via vacant d orbital or via hydrogen bonding. So in CCl4 both the case not possible. It cannot hydrolyze via hydrogen bonding or vacant orbitals are not there. Now it is a very classical example, old example given in NCERT. Okay, this used what? sp3 hybridization. So lone pair will decrease from 109 degree 28 minute to 107. They are using pure p orbital because bond angle 93 degree, 92 degree, 91 degree. They use what? Pure p orbital. Understood? Pure p orbital, very small atom hydrogen, so it will cause little bit repulsion. So 91, 92 and 93, these are the classical. All are gases, mind it, all are poisonous gases. Also memorize the boiling point order and melting point order of these species, very common question, as well as the basic strength. Now next page, important example. Nitrogen atom NCl3, explosive. NF3 is little bit stable, NCl3 is almost unstable and explosive. It can be hydrolyzed, no doubt. So bond angle is 107 degree, 102 degree, same classical thing that you can use. Chlorine is less electronegative as compared to fluorine. So the bond pair of these are the bond pair. These are the lone pair, these are the bond pair. Bond pair shifted towards fluorine. When bond pair is away from the central atom, the mutual repulsion of bond pairs will be less effective. Okay, and the new concept you can apply, the size of halogen. Similarly here also the same classical example, but see here you can observe 107 degree, 100 degree. Why such difference is there? नाइट्रोजन के बड़े वैसा फास्फोरस है ना, नाइट्रोजन के बड़े वैसा फास्फोरस. Why such difference is there? कि NCl3 bond angle is 107 degree and PCl3 bond angle is 100 degree. Why such difference is there? Okay, so we can use the same classical concept. Nitrogen is more electronegative than phosphorus, so bonded pair will be closer. Now we are contradicting to each other. See, here we can compare the terminal atom is in both molecule is chlorine. Understood? The terminal atom in both the molecule is chlorine, so we cannot compare with respect to chlorine. We have to compare with the help of central atom. Central atom. Okay, so now we will use the electronegativity of central atom. Moreover, the size difference is there, so here it will use the 3p, that one will use 2p. Okay, that difference may be there also, so mind it, memorize it and keep in mind. It is again classical example, NCERT. Same thing, the acidic nature order. Okay, only water is liquid due to hydrogen bond, remaining are the gases. Remaining are the gases. Okay, and the bond angle. Next is NiCN6 minus. It is a hexacyanido C nickelate second complex. Hexacyanido C nickelate complex. So one by one when we add ligand, so it is become interesting from here. NiCN whole 4, that will be 2 minus, right? Suppose you want to determine the structure of this. So being a strong field ligand, it will pair up. So 3d8, 3d8 paired up, 3d8 paired up, it will be square planar. Square planar. These are intermediate species, minded, these are intermediate species. Now we will go to NiCN whole 5, 3 minus. It is also given in the resonance sheet. Very good example. It is not TPP because it use what? D, x square minus y square. So it is square pyramidal. Pyramidal. Understood? Now you will go for NiCN whole 6, 4 minus. Obviously it is as DSP, D2, SP3 and octahedral complex. Okay, so these are the step-by-step formation of the I'll explain this in physical as well as in coordination chemistry revision. Now, this is the homework. Go for this. Xenon trifluoride cation, ICl4 minus, anion. Very famous question, old PYQ. I2Cl6, I2Cl6, I2Cl6 liquid phase conduct electricity. Why it conduct? Because it ionize in liquid state. ICl2 plus cation and ICl4 minus anion. Okay. Then there is an interesting molecule BRF5, old classical question of the advance, where the multiple answers are given and everybody awarded the marks. Okay. So BRF5, how to make it? Bromine with 5 fluorine excess. Temperature is 150 degrees Celsius, you will get BRF5. Another method for better yield and no impurity of trifluoride. We can use KBr along with 3F2. Okay. The uses, it can be hydrolyzed. It can be hydrolyzed because of the vacant d orbital, availability of the vacant d orbital. So water can act as a nucleophile. So it can be hydrolyzed, that we will discuss and do it. Those who know how to hydrolyze such molecules, memorize. During hydrolysis, oxidation number will not change. So bromine will be in +5. So +5 oxy acid will be there. Understood? It is also used to get what? UF6. UF6. Uranium hexafluoride. Why to get this compound? It is a isotopic enrichment method. In nature, uranium 238 is bhar ke, khub sara, almost 99%. And uranium 235, which is fissile. Fissile. The word is fissile. Fissile. So fissile uranium 235 is very little in nature, hardly 1% or less than 1%. So how to separate uranium-235 from uranium-238? We need isotopic enrichment. And you know the diffusion thing. Diffusion thing is only possible in the gas phase. So we have to convert into UF6, which is in gaseous phase. So the gas phase diffusion, higher molar mass gas will diffuse slow. The lower molar mass gas will diffuse fast. Okay. So by the relative diffusion, we can separate uranium-235. That is known as isotopic enrichment. Last page. Last page is a question. Okay. Those who are focusing 80 or 80 plus marks in advanced only in chemistry. This is a good question. Okay. The geometry of this molecule is square pyramidal. Okay. Suppose I put 2 chloro here, then what could be the geometry of this molecule? This is the question of the day. And time check. Done? Okay. Thank you for today. And before watching this lecture, please watch VSCPR 1 and VSCPR 2. Thank you very much.